A regime is a characteristic set of behaviors of a system, which is maintained by mutually reinforcing processes of feedback. A regime shift is a qualitative, abrupt, and major change in the topology and functioning of a system. These regime shifts are non-linear in that they usually occur suddenly when a smooth change in an internal stabilizing feedback process or an external disturbance triggers a completely different system's behavior. These regime shifts have been studied most comprehensively within ecology. The classical example is the shift from a clear water lake to a eutrophic lake. But equally, the concept of a regime shift applies to all kinds of systems. Political regime shifts involve periods of revolutionary change in the socio-political structures that govern a society. During these periods, the major forces acting on and influencing the social system are reconfigured rapidly. These changes may be termed a social or political revolution, which typically occurs rapidly and involves basic transformations in the society's state and class structures. Because regime shifts involve a transition in the whole structure of a system, they are inherently nonlinear processes of change, also called higher-order change. The general theory of regime shifts is based on the study of nonlinear dynamical systems that developed during the latter half of the 20th century. This framework is constructed out of a number of models from chaos theory, complexity theory, and systems theory, including ideas surrounding feedback loops, state space models, bifurcation theory, and attractors. The dynamics of nonlinear systems are understood mathematically with respect to a model called the state space. In mathematics and physics, a state space of a dynamical system is a space in which all possible states of the system are represented, with each possible state corresponding to one unique point in the phase space. The state space is a model that maps out the different parameters that define a system. For each primary parameter to the system, there is a corresponding axis. A one-dimensional system is called a phase line, while a two-dimensional system is called a phase plane. But the system may have many more dimensions, each corresponding to the most important three parameters that define the system's dynamics. A point in the state space then corresponds to a specific state of the system at any given time, as defined by the values of the corresponding parameters. As an example of this applied to interpreting social systems, we might think of the World Values Survey as a kind of phase space. The World Values Survey is a global research project that explores people's values and beliefs, how they change over time, and what social and political impacts they have. The axes of the model represent two major dimensions of cross-cultural variation in the world. The first dimension is that of tradition versus secular rational values, and the second dimension is that of survival versus self-expression values. The global cultural map then tries to capture the relationship between different socio-cultural systems by looking at their location within these two dimensions. Moving upwards on this map reflects a shift from traditional values to secular rational values, where traditional values emphasize religiosity, national pride, respect for authority, obedience, and marriage. Secular rational values emphasize the opposite on each of these accounts. Moving rightward reflects the shift from survival values to self-expression values. Survival values involve a priority of security over liberty, non-acceptance of homosexuality, abstinence from political action, distrust in outsiders, and a weak sense of happiness. Self-expression values imply the opposite on all these accounts. This same graph could of course be used to define the state of a socio-political system with respect to any two or more free parameters. As the system's state changes over time, this then traces a corresponding path through this higher dimensional space. The phase diagram traced out by the trajectory of the system as it changes over time represents all that the system can be, and its shape can easily elucidate qualities of the system that might not be obvious otherwise. Typically, what we see when looking at the phase space of a system is some form of a cycle to its behavior, as it moves through a specific set of states, but generally stays within the same subsection of the overall phase space. In general, systems may initially explore their full state space, but over time they settle into some subset of the entire phase space, like putting a ball into a bowl as it rolls around before settling into a stable state. Or for example, we might think of going to live in a new city. One may initially explore the whole city, but then, after settling down, one's movement becomes confined within some subset of locations within the whole city. Due to certain constraints, such as having to work, visit friends, or do shopping, one finds that one's movements start to form a coherent pattern within certain limited confines of the overall city. This typical, stable behavior to a system towards which it naturally gravitates over time, we call an attractor. For example, when the person first arrives at the city, they may go exploring in many different directions, but once their lives have become routinized, if we put them anywhere in the city, they will invariably return back relatively quickly to their pre-existing pattern. Thus we can say an attractor or basin of attraction forms the typical set of states towards which a system will converge, given any arbitrary value of its initial conditions. This basin of attraction may be cultural, as in the World Value Survey illustrated previously, where a certain subset of ideas dominate within a society, working to shape opinions and perspectives. But it may also be social, where certain political rules shape the actions. It may also be economic, where the financial constraints maintain people within a certain pattern, such as going to work in a particular job every day. This basin of attraction is constructed out of a set of forces that are acting on the system to contain it within a certain well-defined pattern. A basin of attraction, then, forms a specific regime within the system, that is to say, a set of forces that are acting on the individuals to shape and organize their behavior. These forces that work to constrain behavior within a given pattern or to create change can be understood in terms of feedback loops. Feedback loops capture the essence of interdependence between elements over time. The model of a feedback loop describes how two variables affect each other over time through a cyclical interplay, where what happens to one now will affect another, which will then feed back to affect the first. Feedback loops are a very basic model in their essence, but also have an extraordinary descriptive capacity, as many dynamics can be understood in terms of feedback loops that are at the heart of all processes of nonlinear change, from population dynamics in ecosystems to financial crisis to the rise and fall of political regimes. Feedback loops come in two kinds, negative and positive. A negative feedback loop is where a change in one variable induces a change in another associated element in the opposite direction, thus working to counterbalance the movement in each and create stability. Positive feedback is where a change in one induces a similar change in another, where two things are moving in the same direction over time. They move up or down together as they both reinforce each other's change through this feedback dynamic. Negative feedback is inherently stabilizing through the balancing mechanism that the loop creates. Punishment systems can be seen as a form of negative feedback loop that is designed to maintain the status quo within the system. The threat of punishment is designed to counterbalance the reward within the subject's mind with something negative, and thus to prevent them from taking a certain action. The less obedient they are, the more they will be punished. The more obedient they are, the less punishment they'll receive. Thus, the feedback mechanism works to correct their behavior and keep them on the desired course. Negative feedback is what we might call normal, in that it works to maintain things in a stable, steady state. In this sense, negative feedback is inherently conservative, in that it's always working to maintain the existing state of the system or regulate gradual processes of linear change. Positive feedback is the opposite from this, as it is inherently destabilizing because everything is going off in the same direction. An autocatalytic reaction in chemistry is a good example of a process driven by positive feedback. Autocatalysis is when a chemical reaction creates more reactions, which in turn create even more reactions. Thus the rate of change is compounded as it speeds up over time. The author, Jared Diamond, in his book Guns, Germs and Steel, used this concept to explain how certain technologies cause civilizations to develop at an exponential rate, making it difficult for societies that develop technologies later to catch up. The reason this happens is that technology builds upon itself. In other words, one innovation depends upon many others. Gutenberg's printing press, for example, depended on several other innovations, including a screw press used previously to make olive oil and wine, as well as innovations in paper making. When we view the development of technology historically, we can see how it provides its own momentum, compounding upon itself. The more technology a society has, the more it can develop. Due to this compounding effect, positive feedback processes can happen at an exponential rate of change. They are typically short-lived, but drive major change within the overall system. When positive feedback becomes dominant within a system, it is a sign of a regime shift. The whole system is moving into a new regime at either a higher or lower state of operation. In times when a system is in a strong, stable basin of attraction with much strong negative feedback acting on it, it is invariably resistant to outside influence and will not change easily. We may say that it is topologically closed, as many processes are balanced and contained within that specific basin of attraction, creating negative feedback. A society in a normal state has a strong basin of attraction that represents the mainstream of people that are incentivized to stay within that existing pattern. Balancing negative feedback loops are linear in nature. They produce normal Gaussian distributions where everything is mainly in the middle of the distribution. The pattern has a sense of coherence in that it is closed, and it has a sense of being balanced in the sense of fairness or justice. For example, if you work hard, you'll get remunerated for it. Here, we might think about the heyday of the American middle class in the 1950s and 60s, when one wage earner earned enough to buy all the goods of a middle-class lifestyle because everything was cheap relative to their wage. Working a normal job would suffice to maintain a normal level of economic well-being with a corresponding large and dominant middle class. Change happens when the balancing feedback mechanisms that hold the system within a certain basin of attraction become broken. Positive feedback becomes more prominent, and the system shifts from a linear to a non-linear paradigm with a corresponding behavioral change. A move from normal distributions to power law distributions, from equilibrium to non-equilibrium, from incremental change to exponential change. For example, the global biosphere is regulated by many distributed balancing feedback loops that hold the overall ecosystem within a specific set of states. As human industrial activity breaks these feedback loops, the basin of attraction becomes weaker, and it starts to move away from the equilibrium within which it was held as we experience more extreme events out on the edges of the distribution. The same is true for socio-political systems. When basic negative feedback loops, such as that of work and remuneration, crime and punishment, supply and demand, skills and employment, become disintermediated or broken, the system will become more non-linear and start to act in a new way. The negative feedback is what holds elements within the pattern. The weaker they are, the further from the equilibrium they can move, out to the fringes of the basin of attraction, where they once again become influenced by external forces. As positive feedback becomes more prominent, it becomes easier and easier to influence the system, and it takes longer for the system to return to a normal state after an external alteration, and we call this critical slowing down. During this process, the system does not just stay cycling within a given pattern, but parts of the pattern may start to move into new locations within the overall state space and form a new regime. A process whereby an attractor splits into two or more attractors within the overall state space is called a bifurcation. Bifurcation theory studies qualitative changes in the topology of a state space. A bifurcation occurs when a small, smooth change made to the parameter values of a system causes a sudden, qualitative or topological change in its behavior. This may be deemed a critical state to the system, in that small change can have major effects in determining the long-term trajectory of the system into a new basin of attraction. As the pattern becomes eroded, more elements move away, and a new pattern forms, thus creating a bifurcation. During the transition, the system exists in what is called a state of bistability. In a dynamical system, bistability means the system has two stable equilibrium states. Something that is bistable can be resting in either of two states, which is not the case during normal periods when there is only one dominant basin of attraction, one stable state that corresponds to what we call the mainstream within a society or culture. As noted, these periods of regime shift are transient in nature. They often involve the consumption and expenditure of unsustainable amounts of energy. Just like in an autocatalytic chemical process, they will not last long, and the system has to explore new possibilities. It has to rapidly iterate to find new solutions and a new basin of attraction, or it will run out of energy and collapse back into the old regime. Just like in a major political protest, the system can't stay in a high-energy, non-equilibrium state for long, and new solutions have to be quickly found and developed. As Professor Eve Middleton-Kelly notes, what happens is when a system is pushed far from equilibrium, the following characteristics come into play to create the new order. It will self-organize, it will explore possible solutions, it will co-evolve, new structures will emerge, there will be a sense of coherence, but also the precise behavior can be neither predicted nor controlled. Likewise, the social and political scientist Immanuel Wallerstein speaks of this process as such. When a system, any kind of system, enters a moment of bifurcation and is, therefore, coming to an end, two things happen. The structure becomes chaotic, and secondly, it becomes one in which small input gets great output, as opposed to a normal functioning system in which great input gets great output. This is very important to remember because that means we are in a chaotic, confused situation in which there's going to be a real struggle about the new order. Unlike 50 or 100 years ago, when we worked very hard and organizations worked very hard and didn't get very far, the revolution didn't turn out to be so revolutionary. Now, every little input will get very great output. Every little touch by us in the next 20 to 50 years is going to have a big impact, and it may not be the impact that we want if we touch it in the wrong way. This final process of change, when the system has reached a critical state, may be termed a social or political revolution. At such critical points, the system becomes highly nonlinear and chaotic, as smaller and smaller events can determine larger and larger outcomes. This process of change is nonlinear in that each individual's costs and benefits of changing to the new regime depends on the number of other people who do so concurrently or did so in the past. A person who publicly opposes the incumbent regime pays an external cost that decreases with the size of the public opposition accumulating over time. The incentive of the individual at any iteration is contingent on the number of people that have already adopted the new state. which creates a positive feedback dynamic. Thus we get tipping points, where a process can start slowly, but once it's gained traction can happen at an exponential rate. Models to such processes of political regime shifts are usually looked at in terms of the cost-benefit of the individuals, which is contingent upon the level of opposition and the power of the regime, the level of discontent of the individuals, the capacity of the members to connect and organize. But also, the triggering of the action depends in a great way on the specific distribution of the members. In her 1979 book, States and Social Revolutions, the sociologist Theda Skocpol conducted an in-depth analysis of the process of revolution by looking at the French, Russian, and Chinese revolutions. According to Skocpol, revolutions involve a transformation in embedded institutions. A social revolution involves total social and political structural change to society as a whole. Skocpol asserts that social revolutions are rapid and basic transformations of a society's state and class structures. The author made an important distinction between a revolution and a rebellion. For her, a rebellion is simply an uprising by subordinate classes, which may not cause structural changes. Revolutions, on the other hand, occur when embedded institutions are transformed. A social revolution involves total political and social structural change to a society. She asserts that nothing is left the same afterwards. Skocpol examined examples of social revolutions from the history of Russia, China, and France. She believed that all three displayed the same core features. Firstly, a social revolution required an old regime that based its power on maintaining traditional forms of economic organization. Secondly, the occurrence of a crisis, usually in the form of external pressure, was needed to weaken the grip of the ruling class. Thirdly, a rebellion was led by the lower classes. And fourthly, a new regime was developed and became accepted as legitimate. She argued that the state's ability to respond to a crisis depended on its structure. If it is able to react and effectively respond, then a revolutionary situation will not come about. If it is not, then the social revolution will likely ensue. A regime is a characteristic set of behaviors of a system, which is maintained by mutually reinforcing processes of feedback. A regime shift is a qualitative, abrupt, and major change in the topology and functioning of a system. These regime shifts are non-linear in that they usually occur suddenly when a smooth change in an internal stabilizing feedback process or an external disturbance triggers a completely different system's behavior. These regime shifts have been studied most comprehensively within ecology. The classical example is the shift from a clear water lake to a eutrophic lake. The general theory of regime shifts is based on the study of nonlinear dynamical systems that developed during the latter half of the 20th century. This framework is constructed out of a number of models from chaos theory, complexity theory, and systems theory, including ideas surrounding feedback loops, state space models, bifurcation theory, and attractors. The dynamics of nonlinear systems are understood mathematically with respect to a model called the state space. In mathematics and physics, a state space of a dynamical system is a space in which all possible states of the system are represented. We might think of the World Values Survey as a kind of phase space. The World Values Survey is a global research project that explores people's values and beliefs, how they change over time, and what social and political impacts they have. The axes of the model represent two major dimensions of cross-cultural variation in the world. The first dimension is that of tradition versus secular rational values, and the second dimension is that of survival versus self-expression values. The global cultural map then tries to capture the relationship between different socio-cultural systems by looking at their location within these two dimensions, moving upwards on this map for each possible state corresponding to one unique point in the phase space. The state space is a model that maps out the different parameters that define a system. For each primary parameter to the system, there is a corresponding axis. A one-dimensional system is called a phase line, while a two-dimensional system is called a phase plane. But the system may have many more dimensions, each corresponding to the most important three parameters that define the system's dynamics. A point in the state space then corresponds to a specific state of the system at any given time, as defined by the values of the corresponding parameters. As an example of this applied to interpreting social systems, but equally the concept of a regime shift applies to all kinds of systems. Political regime shifts involve periods of revolutionary change in the socio-political structures that govern a society. During these periods, the major forces acting on and influencing the social system are reconfigured rapidly. These changes may be termed a social or political revolution, which typically occurs rapidly and involves basic transformations in the society's state and class structures. Because regime shifts involve a transition in the whole structure of a system, they are inherently nonlinear processes of change, also called higher-order change.